Okay. Hi, everybody. So today is February 7. We're going to talk about 7.6 numerical integration. And we just postponed the exam 1 to the Monday, February 19th, so you can have more time to study for it. So you took the quiz 2 days ago, right? And I have already finished grading it. So to see the quiz solution, scroll down our course website. And you see, this is quiz 1 solution. Let's take a look. So the first problem. Okay, so the first problem, we use the u substitution. Let u be 4x cubed plus 1. Du is 12x squared dx. But we have x squared dx. We don't have the 12. So both sides divided by 12. And then x squared dx is 1 over 12 du. Put the 1 over 12 in front of the integral du at the end. And then this becomes e to the u. The integral of e to the u is e to the u. Okay, remember integral of e to the ax is 1 over a, e to the ax. But in this case, it's like e to the 1 times u. So a is like 1, okay? Yeah. And then we just put the x back. That's number 1. Number 2. So we have a definite integral. We're gonna integrate it and plug in the expands the values. Integral 5 stays here. Integral of 1 over x is natural log of absolute value of x. 8 stays here. Integral of x cubed is x to the 4th over 4. And 2 stays here. This is x to the 1/2. When you add 1/2 to it, is x to the 3/2 over the new exponent 3/2. But you put the 2 upstairs, right? So it becomes 2 times 2 is 4/3. So you plug in the y, subtract, you plug in the 1. So you can use your calculator. So round your answer to 3 decimal places. You get 107.554. So that is the quiz solution. Let's look at the quiz mistakes. So first of all, may I ask your permission to print screen your quiz mistakes so we can go over it all together? Of course, I won't print screen your name. Can I have your permission?
You could do my whole thing.
Okay.
I got 9 out of 10, so cool.
Okay. I see. Okay, I forgot to change the permissions. Okay, let me see.
It looks like that your steps that you gave us helped me figure out how to do it.
Oh, okay.
Yeah.
Yes, good. So quiz mistake. Okay, I need to change my. Okay, everybody with the link. Okay, now it should work. So let's try again. Okay, now it works. Okay, so yes, we learn from the mistakes. You know, sometimes I make mistakes too. So we are like a family, sisters, brothers. Okay, so we just learn from mistake our teachers, right? Okay, so here the mistake is you need to integrate before you plug in the numbers. Okay, so integrate first, then plug in the numbers. And I know the quiz problem, and when you need to copy the problem from the quiz sheets to your notebook, make sure you double check. Okay, so it's integral from 1 to e. Yeah, we're gonna integrate first, then plug in the numbers. And here, for definite integral, you don't need plus c. Because if you put plus c, then you have like plus c here. You see my mouse? You plus c here and subtract plus c here. So c minus c is gone. So we don't have this plus c. And this number is 107. Point, is it 554? Yeah, 107.554. Okay. Oh, Maybe the mistake is forget the parentheses. You see, everybody? Forget the parentheses. Then this plus become minus. Yeah, make sure you put the parentheses around them. Okay. And then here, integral of e to the u is e to the u. We don't put the u down there. So integral e to the ax is 1 over a, e to the ax. Do we put the x down there? No, just the coefficient of x. In this case, coefficient of u is 1. Okay? So don't divide it by u. Okay. So keep going. Yeah, absolute value of x. And then this is plus. Okay, yeah. And then here, I prefer you combine them together and put x to the 3/2. Then you know over 3/2. So that is the same as you multiply by 2, then over 3. Okay. Oh, that's it. Any questions about the quiz? So we learn from it. I hope you can do well on the exam. Okay, so again, the quiz solutions and quiz mistake are on the website. Okay, so let's continue. Did we finish all of track 7.5? Okay. Oh, we didn't finish like the last problem? Okay, let's see. Oh yeah, we were working on the consumer surplus and the producer surplus, right, everybody? Okay, let's continue work on that. Yeah, we solved the system of equations and we found the intersection point. And we see the Q cannot be 55 because then our demand will be negative. Demand and supply should be positive because the price should be greater or equal to 0. Okay, I would say greater than 0. It doesn't make sense. It's 0. Otherwise, it's free, right? Okay. So let's continue. Consumer surplus, right there. So CS. So CS is integral. Where's X? Where to where? I mean, what is the Q? Where to where? So we want to compute this area. 0 to 40. And then we use the upper function minus the lower function. Upper function is the demand, right? 47. So, or you can put demand minus the price, which is 7 DQ. And now our demand is 47 minus Q. And then minus the price is 7. Right here, you see the lower function is the constant function 7. Yes, everybody? Okay. Let's combine them. Well, we have the constant 47 minus 7 is what? $47 minus 7 is 40. So we have 40 minus Q, DQ. Oh, that's the attendance. Thank you. Okay, so let's integrate that. What's the integral of 40? 40 times Q, right? What's the integral of Q? Yeah, Q squared over 2. Evaluate from 0 to 40. Right, everybody? We plug in 40. So 40 times Q is 40 minus q squared. 40 squared over 2. Yes, everybody? So what is 4 times 4? 1600. And then, 40 squared is 1600 over 2 is 800. What's 1600 minus 800? Yeah. So the consumer surplus is 800. 40 times 40. 40 minus q. Oh, integral power rule. So q to the 1 plus 1 is q squared, and then over the new exponent.
Okay.
Yes. Okay,
so then why is it 40 times q?
40 times q?
Oh, because you add the q. Okay,
Yeah.
Okay,
Every time we integrate, we increase the power of q by 1. Yeah. So constant term becomes linear term, and the 0 becomes constant. See, yeah. Okay, so that is consumer surplus, right? Let's keep going. Producer surplus. So C, producer surplus is right here. Okay, from the picture, our Q is from where to where? 0 to 40. And then we use the upper function. Who's the upper function? Upper function is constant function 7, right? That's the upper function. We draw a picture here. That's the upper function. And the lower function is the supply. So we can use 7 minus supply, dq. And supply is square root of q plus 9, dq. Is that okay, everybody? Supply is that. So upper function, the constant function 7. And then minus the lower function is the supply. It's square root of q plus 9. Right, everybody? Okay, what is integral of 7? 7q. Yes? And we evaluate from 0 to 40. The next parts, let's break them. So this is integral square root of q plus 9 dq. So the 7q, yeah, we can calculate that by putting in the 40. But this part, do you see this is not one of the 3 types we learned? It's not like x to the power or exponential function or 1 over x. It's not that. But it's a square root of something, right? It's like a composite function, so we can use U substitution.
So what if you would turn it into 1 over 2, but they're at half power.
Yes.
Could you split them instead?
No, yeah, this is really, really good questions. So if you have square root of a squared plus b squared, this is not equal to square root of a squared plus square root of b squared.
Okay.
Yeah, but if you have square root of a squared times b squared, yeah, it's square root of a squared times square root of b squared. So for multiplication or division, you can split them. But for subtraction or addition, we cannot do that.
Okay.
Yes. That's a very good question. Okay, so we continue. So 7 times we plug in q is 40, right? And minus we plug in q is 0. Okay, then minus this part. Let's calculate that part. So we calculate this part. Okay, and then after we calculate, we put the number here. So we let u be what? Yeah, q plus 9. Then du is what's du? And q is the variable. What's the derivative of q?
Would be the half. Or no, so derivative of q
Yes.
would be 1.
Yeah, be 1 dq. Yes, everybody? So now let's calculate the indefinite integral to make it easier. So we calculate the indefinite integral. This is like u square root of u, and then dq is du. Is that okay, everybody? Right? Let's calculate the indefinite integral, and then we get the x back, then we can plug in. So what is square root of u? U to the 1/2, right? And how do you integrate u to the 1/2? U to the 3/2 over 3/2. But what do you do to the 2? Yeah, move it upstairs becomes 2/3 plus c. And now, so 2/3, what is u? Q plus 9. Is that okay, everybody? This is the indefinite integral. Now our definite integral. So evaluate from 0 to 40 is this 2/3 cubed plus 9 to the 3/2. Evaluate from 0 to 40. So we plug in 40 first, right? So 40 plus 9 to the 3/2 minus, we plug in 0. So 0 plus 9 to the 3/2. Ooh, they're a nice number, right? 40 plus 9 is 49. Okay, the half means square root. What's square root of 49? 7. So this is like 7 cubed. So 2/3 times 7 cubed minus 2/3. See? This is 9. What is square root of 9? 3. So this is 3 cubed, actually. So multiply by 3 cubed. Okay, plug this in your calculator. What do you get? Give me a fraction. Will your calculator give you a fraction? What do you get?
210 and 2/3.
Improper fraction. Okay, give me an improper fraction. So what do you get? Will your calculator give you improper?
Mine won't, no.
Oh, they won't give it. Okay. 2 tens and what? 667. Okay. Yeah. Okay. It's okay. So we can use that decimal. Yes. 632/3. Okay. Yeah. That is exact. Good. And then our PS produce a surplus. What's 7 times 40? 280, and 7 times 0 is 0, minus the 632 over 3 is what? Or give me a decimal. If you could decimal around to 3 decimal places. 54. Thank you. Oh, 33. Is it 33?
Oh, yes, it is.
Oh, okay, yes. Okay, everybody? Yes. So this is the consumer surplus and producer surplus. Any questions about computing the area? All good? Okay. So let's look at the last session, 7.6.
Generally, do you prefer fractions or decimals?
If it's simple fraction, like the denominator is like 3 or 17, not like hundreds, I prefer fractions. It's because it's exact number. Okay, if you want like more decimal places, then or maybe 4 decimal places or 6 decimal places, you just compute as needed, but it's exact. But if your answer like has exponential function or natural law, there's no way you can get you have to get a decimal, so you cannot get a fraction form. Yeah. But in the exam, you get full scores no matter which form you like.
Okay.
Unless the problem said, give me exact answer.
Okay.
Yeah.
So, like, if you're asking for 3 decimal places, you want 0.333, right?
Yes, exactly. Good. Okay, so then 7.6, we have the numerical integration. This is the last session of this chapter. And I print out the concept map for you. Okay, so this is the chapter 7 concept map. I'm still making more about other chapters. So this concept map like review what method and what formula we learned in this chapter. But I hope you can like remember all of these. If you can hide this and then draw the concept map again by yourself, it would be great. Because that really means you fully understand everything on this chapter. Okay, so numerical integration. So numerical methods for integration are very important because even simple functions may not have exact formulas for their antiderivatives. So right now we only learn 3 types of integrals, like the power rule, x to the n, or exponential function, or 1 over x. But there are a lot of different functions of like different formula that we're not able to integrate. Unlike derivative, if I give you a function, you can always find the derivative. So it might be a combination of product rule, quotient rule, or chain rule. It just takes time, but you can find it. Okay? But for antiderivative or integral, most of the function we're not able to find the antiderivative and get a nice formula. Okay? So that's why numerical integration is so important. In session 7.3, we talk about definite integral. We talk about using the Riemann sum. Yes, do you do your homework about the Riemann sum? You tell it and make a lot of rectangles, either using the right endpoint or the left endpoint. But those rectangles you see, it's quite different than the actual area if the number of rectangles is not big, right? Actually, the better way to approximate the area instead of Riemann sum. Okay, Riemann sum, you have to do a lot of rectangles, then your approximation will be more accurate. So there are other methods where you don't use rectangle, you use, for example, trapezoid. Okay, here we're going to talk about the trapezoid method and the Simpson's method. And to approximate it. So then you can have like less interval. So you separate the interval into smaller intervals, and you're gonna use trapezoid to approximate it. And the approximation is much better than the Riemann sum. Okay, so in the next exams, so exam 1, I won't ask you to approximate using the Riemann sum because I just ask you to use the trapezoid method or the Simpson's method because it's more accurate than the Riemann sum method. Okay, let's look at the trapezoid method. Oh, thank you. Okay, so trapezoid method. Let's look at the picture. So we have the area. We want to find the area under the curve from A to B, right? Let's use one trapezoid to approximate it. So we use A and B, and then we use this endpoint and this endpoint, the height, to draw the trapezoid. Do you still remember the formula of the trapezoid? Is 1/2 of the area of the parallelogram, right? You get another copy of trapezoid, put it upside down, we get a parallelogram. And we know for the parallelogram is base times height. Do you see that new base is A plus B and times height? So therefore, using the formula of trapezoid, in this case, do you see our trapezoid is like laying down like this? And with the height is the difference between A and B. So the height is B minus A. And now you see the base is actually f of A plus f of B. Okay, everybody? So this is the trapezoid rule. Compare with the Riemann sum. If you use Riemann sum, if you use the left endpoint, this is what you get. If you use the right endpoint, this is what you get. Do you see it's quite different than the actual area? Your trapezoid, I would say more accurate, maybe more closer. The approximation is better. Okay. All right. So therefore, we get, if we use one trapezoid, then this is the formula, yeah? B minus A over 2 f of A plus f of B. That's one trapezoid. Now, what happens if we use two trapezoids? Okay, so that is A and B, two trapezoids. So we have the midpoints. Like let's call this is x0, and this is called x1, and this is x2. And then our height. You see the height now is B minus A, and then divided by 2 because we cut it into two subintervals. Okay, so two trapezoids. That is H. And now our integral from A to B is the integral from A to x1 plus the integral from x1 to B. Okay, everybody? So that's why the height is H. So we have 1/2 H, and then times f of A plus f of x1. This is the trapezoid, the first trapezoid. The second trapezoid is still H over 2. The height is still H over 2, and then times f of x1 plus f of b. Is that okay, everybody? Therefore, what happened? This is still H over 2, but you know H is B minus A over 2, so H over 2 becomes B minus A over 4. Okay? And then look at this. We have f of A, but do you see we have two copies of f of x1? Because this height is one side of the left trapezoid, is also the side of the right trapezoid. You actually add it twice. And then f of b is one copy. Is that okay, everybody? This is the picture when we have two trapezoids. Now, next. How about we have n trapezoid? So I would say I would say use the formula h over 2 is better. Okay, because h over 2 is better. But then you remember what is h? H is b minus a over n. and you call A to be x0, and then x1, x2, xn. Okay? Now the height is h. So therefore your trapezoid is h over 2, and then your A, f of A, 1 copy. F of x1, 2 copies. So all the interior points, the height, 2 copies. Because it's the side of the previous trapezoid is also the side of the next trapezoid. We count it twice. So all the interior points, 2 copies. And then the end point, 1 copy. So this is the formula for the trapezoid. H over 2, H is B minus A over N. And then times the end point, 1 copy. The interior point, 2 copies. Is that clear, everybody? Okay, now let's do this exercise. Consider the integral. So we integrate. If we want to draw the picture, this means we have the function 1 over x. You know 1 over x looks like that, right? Hyperbola. And it's from 1 to 2. So we're talking about the area here. Okay, so this is 1 over x. We're talking about the area. So part A computes the exact value of the integral. Yeah, this integral we're able to compute. And then part B approximates this integral using the composite trapezoid rule with n equals to 4 subinterval. What is the absolute error of the approximation? Okay, now let's see. Part A, compute the actual value. So integral from 1 to 2 dx over x. What's integral of 1 over x? What's the integral of 1 over x? ln, absolute value of x, right, everybody? ln, absolute value of x. Evaluate from 1 to 2. So we plug in 2 first, minus, we plug in 1. What's natural log of 1? What's natural log of 1? See, natural log of 1 is 0. So the answer is just natural log of 2. Okay, give me as many digits as your calculator show you. Yeah, ln 2 is what?
As many digits?
Yeah, as many digits. Thank you. 0.693147181. Thank you. Okay. Yes, because we want to compare our approximation with this number. Let's see. Now we use the composite trapezoid rule with n equals to 4 subinterval. Okay, so I suggest everybody draw the picture of the interval. So we're from 1 to 2, okay? And we want to cut it into 4 sub-interval. Tell me what's the midpoint of 1 and 2? 1.5, right, everybody? The midpoint of 1 and 2 is 1.5. And then what's the midpoint of 1 and 1.5? 1.25. And what is the midpoint between 1.5 and 2? 1.75. Yes. Is that okay, everybody? Mm-hmm. So that is the interval from 1 to 2, and we cut it into 4 subintervals. Then H. H is the step size. Which is the difference between 1 and 1.25? What's that? 0.25, exactly. Okay, now the trapezoid rule tells us that it's h over 2. So h over 2. And then f of the first endpoint, f of 1 copy. And then f of the next point, 2 copies. So all the interior points, bless you, 2 copies. So 2 copies f of 1.5 and 2 copies f of 1.75. And f of 2, how many copy? 1 copy f of 2. So keep this in mind. H over 2. Because that's the trapezoid. Trapezoid area is 1/2, and then pi times the sum of the two sides, right? So that's why it's h over 2. And then the end point, 1 copy. All the interior points, 2 copies.
So this is lengthy.
Yes.
What happens when the trapezoid is massive?
In the exam, my n will be just like 4, 6. It won't be so big. Okay, but if it's so big, we need to use computer. So MATLAB,
Okay.
we can use MATLAB, and then you can set up your n as big as you want. 1,000, 2,000.
Not
Yeah.
MATLAB. I hate MATLAB.
MATLAB, yeah.
It's cool.
Okay, so let's plug in. Now we have h. What is h?
Which is the height.
So h, yes, 0.25. So 0.25 over 2 f of 1. So the function f of x is 1 over x. Right, everybody? Mm-hmm. So f of 1 is 1 over 1, right? And then 2 times f of 1.25. So 1 over 1.25 plus 2 times f of 1.5. 1 over 1.5 plus 2 times 1 over 1.75 plus 1 copy f of 2. 1 over 2. Okay. Plug this in your calculator and get me as many digits as the calculator displays. Is that okay, everybody? Mm-hmm. So remember the trapezoid method, h over 2. Then the endpoints, 1 copy. The interior points, 2 copies.
Yeah. Let's look into this and see what we use. Yeah.
I do have 4 scientific calculator in my office. So if you forgot to bring your calculator in the exam, you can follow mine. What do you get?
Syntax error.
Oh. Oh, so in your calculator, you can put 2 over 1.25 plus 2 over 1.5. You don't need to put 2 times 1 over that. Just you can put 2 over that. That'll be faster. Sarah, did you get a number? Thank you. Yeah, that's good because 6.69, 8.69, they're close to each other. Yes, they're supposed to be close to each other. Good. Okay, now our absolute. Let me see. Okay. Let me see. I realized I have a. Oh, sorry. I look at the wrong page. Okay. Let me see. Oh, yeah. That's good. Okay, so absolute error. Absolute error is now you use it's the absolute value of the difference of the approximation and the true value. Okay, what is the difference? True value and the approximation. What's the difference? By the way, the difference between them, I don't remember who comes first because it does not matter. It's absolute value. So I usually just use a bigger number minus a smaller number. Yeah, so then you can use the 0.6970238 minus the previous answer, which is the LN2. So your answer, subtract the LN2, what do you get?
4.4005 times 10 to the negative 10.
Ooh. Okay.
Yeah,
Uh, 0.0038. Thank you. Oh, okay. Yes. Right. Because the difference is the third decimal places. So we get the third decimal. Okay. So this is using the trapezoid method. Everybody clear how to do the trapezoid method? Draw the interval and cut it into, in this case, 4 sub-intervals. And then figure out the step size, the difference between the 2 points. And you can use the 1.25 minus 1, or you can think about is the b minus a. B is 2, a is 1, over n. N is 4. Do you see you get 1 over 4? Which is the same as 0.25. Okay, so you can think of that way. All right. Any questions about example 1? All good, everybody? Okay. So that is trapezoid rule, where we use the 2 endpoint to draw a line to draw a trapezoid. Next method, we're gonna learn the Simpson's rule. So trapezoid, we're using the secant line passing through the 2 endpoints, right? You know what a secant line, right? You have 2 endpoints, two points on the graph, and you draw a line connecting them. This is a secant line. So the trapezoid method, we actually use the secant line to approximate it. Where the Simpson's method, we use a quadratic polynomial to approximate it. So let me ask you, how many points can fix a line? 2 points. So you just need 2 points and then you draw the line. But how many points can fix a polynomial? How many points can fix a polynomial? 3. Yes, you need 3 points to fix a quadratic polynomial. Okay, so therefore here, the Simpson's method, we actually need so one block of the Simpson's method, we need 3 points. Okay, so we have A, B, and the midpoint. You know the midpoint is A plus B over 2, right? Okay, and then those 3 points, we can draw a quadratic function. And then we can compute the area under the quadratic function to approximate it. So this is the formula. Okay, so the formula is h over 3, and then we have the left endpoints 1 copy, and the midpoints 4 copy, and then the right endpoint is 1 copy. So this is one block of the Simpson's method area. But what happens if n is 4? because each block you need 3 points. So n is 4, you actually only get 2 blocks. Okay, everybody? Unlike the trapezoid method, n is 4, you get 4 trapezoids. Right, everybody? But for Simpson's method, you only get 2 blocks. So therefore, the n for the Simpson's method, it must be an even number. It cannot be an odd number. Is that clear, everybody? Because you need 3 points for a line. So the n must be even. Okay, so this is the formula. If you have 2 blocks, you see we still have h/3, but then the left hand point 1 copy, and then this x1 is 4 copy, but the x2, because it's the right hand point of the left block and it's the left hand point of the right block, it appeared 2 times. So that's why it becomes 2 copies. And then x3, 4 copy. And the b, the right hand point, is 1 copy. So it follows the patterns for the interior points is 4, 2, 4, 2, 4, 2 alternates. Okay? So therefore, if we have n in general, then the formula of the Simpson's method is h/3. The way how I remember is the trapezoid method is h/2, right? Because you need 2 points to fix a line, so h/2. And then the Simpson's method, you need 3 points to fix a quadratic function, right? So that's why you need 3. So h/3, and then the left hand point, right hand point, 1 copy. The interior point, 4, 2, 4, 2, 4, 2, 4. It starts with 4 and with 4. Is that clear, everybody? Yes. So that is the Simpson's method. Now, example 2. We do the same integral using Simpson's method. Now, let's see. We draw the picture from 1 to 2. And n equals to 4. Again, what is the midpoint of 1 and 2? 1.5. And then, what's the midpoint between 1 and 1.5? And then here, 7.5. Okay, then what's the h? 0.25. Remain the same, right? H is the step size, the difference between 2 points. Still the same. But Simpson's method, the formula is gonna be h over, instead of 2, we have 3. Yes? And then we have the left endpoint, 1 copy. And then the next endpoint, 4 copies. So 1.25, 4 copy. And then the next point, how many copies? 2 copies, f of 1.5. And next point, how many copies? 4. So 4, 2, 4, 2, 4. And then the right endpoint, how many copies? 1. So f of 2. So the endpoint, just 1 copy. Interior point, 4, 2, 4, 2, 4. Alternates. Is that clear, everybody? Okay, so plot this in your calculator. So 0.25 over 3. F of 1, again, f of x is 1 over x. So 1 over 1 plus 4 times 1 over 1.25 plus 2 times 1 over 1.5 plus 4 times 1 over 1.75 plus 1 over 2. So you can go back to your previous line. So if you still have your phone for the previous line, just go back, change the 2 to 3, change this 2 to 4, change this 2 to 4, and then enter. So you don't need to retype the whole thing. Okay, so if you still have your previous calculation, just change 3 numbers there. then you can get the answer. What's the answer? So go back to your previous one. Just change the 2 to 3. Change the 4. Change the 2 to 4. Change the 2 to 4.
0.69325396.
Thank you. Yes. Okay, so let's continue next class. Okay, so we'll do more examples of the Simpsons method. And next class is also a review. So please feel free to print out the practice exams. So after we finish everything, you guys just do the practice exams. Where is the practice exam? On the website at the bottom. Yeah. Print out practice exam 1. Bye. Have a good day.